Welcome to Astronomy Daily, your daily dose of space and astronomy news. I'm your host, Anna, and we've got an absolutely packed show for you today with some incredible developments from across the space sector. We'll be diving into Europe's triumphant return to space with the Vega C rocket launch, unpacking NASA's latest timeline adjustments for their ambitious Artemis Moon missions, and exploring fascinating new evidence that suggests we might have a mysterious Planet X lurking in the outer reaches of our solar system. We've also got some groundbreaking observations from the Hubble Space Telescope that's given us our closest ever look at a quasar, plus exciting news about the Curiosity rover's next mission targeting some intriguing spiderweb formations on Mars. And we'll round things off with crucial findings from NASA's investigation into the Artemis heat shield performance. So strap in for another fascinating journey through the latest developments in space exploration and astronomical discoveries. First up, some good news. Europe's space program has just achieved a significant milestone with the successful launch of the Vega C rocket from the Kourou spaceport in French Guiana. This marks a triumphant return to flight for the Italian-built launcher after a 2-year hiatus following a failed mission in December 2022. The rocket blasted off at 6:20 p.m. local time, carrying the Sentinel-1C satellite, a crucial component of the European Union's Copernicus Earth observation program. This successful launch represents a critical step in securing Europe's independent access to space, especially important given recent geopolitical challenges that have limited the continent's launch options. The mission's success is particularly noteworthy as Europe has faced several setbacks in its space program recently. The previous Vega C failure had grounded the entire fleet when an anomaly destroyed 2 Earth imaging satellites just 2.5 minutes into flight. This return to service demonstrates the resilience and determination of Europe's space sector. Looking ahead, Vega C is set to play an increasingly important role in Europe's space strategy. Following Russia's invasion of Ukraine, the EU was forced to stop using Russian Soyuz vehicles, making the successful operation of platforms like Vega C even more crucial. Starting from 2025, Italy's Avio will take over the marketing of Vega C launches, marking a new chapter in European space operations. The Sentinel-1C satellite, now heading to its 700-kilometer orbit, will join an impressive constellation of Earth observation satellites, expanding our planet's most extensive radar imaging network. This system plays a vital role in monitoring our environment, from tracking the climate to supporting disaster response efforts. Next, some not-so-good news. In a significant announcement today, NASA has revealed further delays to its ambitious Artemis program, pushing back the timeline for humanity's return to the moon. The next Artemis mission, which will send astronauts around the moon without landing, has been rescheduled from September 2025 to April 2026. The subsequent mission, aiming to land astronauts on the lunar surface, is now targeted for mid-2027. These delays stem from crucial safety considerations, particularly regarding the Orion spacecraft's heat shield. During the Artemis 1 test flight in 2022, the heat shield experienced unexpected cracking and partial erosion during re-entry into Earth's atmosphere. While NASA officials stressed that astronauts would have been safe had they been aboard, the agency is taking extra precautions to ensure crew safety for future missions. I'll have some more on this shortly. Also, the financial scope of the Artemis program is substantial, with estimated costs reaching $93 billion through 2025. Despite these delays, NASA Administrator Bill Nelson emphasized that the revised timeline still puts the United States well ahead of China's announced intention to land on the lunar surface by 2030, maintaining America's leadership in space exploration. The technical team has decided to keep the current heat shield design for the next mission, but will modify the capsule's return trajectory to prevent similar issues. Future missions beyond Artemis II will feature an upgraded heat shield design. While replacing the current heat shield might have provided additional safety margins, it would have resulted in an even longer delay of at least a year. These setbacks highlight the complex challenges of modern space exploration, but they also demonstrate NASA's unwavering commitment to crew safety. The Artemis program remains the flagship American effort to not only return humans to the moon, but also to establish permanent lunar bases that will serve as stepping stones for eventual human missions to Mars. Next up, are we a step closer to solving this mystery? For decades, the idea of an undiscovered planet lurking in the outer reaches of our solar system has captured imaginations. Now, exciting new research from Princeton University has significantly boosted the likelihood that this mysterious Planet X actually exists. The study's findings suggest we might be closer than ever to confirming one of astronomy's most intriguing possibilities. The evidence comes from studying the orbits of objects in the outer solar system, specifically trans-Neptunian objects or Kuiper Belt objects. What makes this research particularly compelling is its expanded scope. While previous studies focused on just 11 of the most distant objects, the Princeton team's analysis included 51 objects, providing a much more robust statistical foundation. The results are striking. The team found that there's only a 1 in 1,000 chance that the unusual alignment of these objects' orbits is random. This strongly suggests the presence of a massive body influencing their movements through gravitational forces. Think of it like seeing multiple boats all being pulled in the same direction by an unseen current. It's a clear sign that something significant is affecting their paths. The study also gives us our best picture yet of what Planet X might be like. The data suggests it's about 4.4 times the mass of Earth, making it either a super-Earth or a mini-Neptune. This hypothetical planet would follow an elliptical orbit more aligned with the known planets than previously thought, though pinpointing its exact location remains challenging since it could be anywhere along its orbital path. The hunt for Planet X isn't just about adding another world to our solar system map. If confirmed, its discovery would revolutionize our understanding of how our cosmic neighborhood formed and evolved. With the Vega C Observatory coming online next year, equipped with the world's largest camera for astronomical observations, we might be just months away from finally spotting this elusive world. In a remarkable achievement, NASA's Hubble Space Telescope has given us our closest look ever into the heart of a quasar, peering deeper than ever before into one of the universe's most energetic phenomena. The observations focused on quasar 3C273, which holds the distinction of being the first quasar ever identified back in 1963. What makes this observation truly groundbreaking is Hubble's ability to overcome the intense glare of the quasar. Imagine trying to spot an ant crawling on the rim of a car headlight while staring directly into the beam. The telescope's Space Telescope Imaging Spectrograph acted like a celestial coronagraph, blocking out the quasar's overwhelming brightness, much like the moon blocks the sun during a solar eclipse. The resulting images reveal what scientists describe as weird things in the quasar's immediate surroundings. Within just 16,000 light-years of the central black hole, researchers have spotted various mysterious blobs and an L-shaped filamentary structure. Some of these objects might be smaller galaxies being pulled into the quasar's monstrous black hole, providing the fuel that powers its incredible luminosity. The team also made fascinating discoveries about the quasar's jet, a massive stream of material stretching an astounding 300,000 light-years across space, moving at nearly the speed of light. By comparing observations taken 22 years apart, they found that the jet actually accelerates as it moves farther from the black hole. This unprecedented view of 3C273, located 2.5 billion light-years away, is helping bridge our understanding between what we see in radio observations and larger-scale optical imaging. It's offering crucial insights into how these cosmic lighthouses interact with their host galaxies and shape the evolution of the universe around them. Let's change gears and get a Mars update. NASA's Intrepid Curiosity rover is gearing up for a fascinating new chapter in its already remarkable mission on Mars. After successfully wrapping up its exploration of the Geddes Vallis region, where it made several significant discoveries, including pure sulfur crystals and ancient lakebed formations, the rover is now setting its sights on something truly extraordinary: massive spiderweb-like structures that stretch across the Martian surface. These peculiar formations, known as the boxwork, span an incredible 6 to 12 miles across and represent one of the most intriguing geological features ever identified on Mars. While similar structures exist on Earth in places like Wind Cave National Park in South Dakota, they typically only extend a few feet. The Martian versions dwarf their terrestrial cousins by orders of magnitude. The boxwork formations are believed to have formed through a process involving mineral-rich water, much like their Earth counterparts. As ancient waters carrying dissolved minerals seeped through cracks in the Martian rock, they left behind crystalline deposits. Over time, as the surrounding rock eroded away, these more resistant mineral veins remained, creating the distinctive web-like pattern we see today. What makes these structures particularly exciting for scientists is their potential to reveal new insights about Mars's watery past. The minerals preserved in these ancient formations could tell us not just about the chemistry of Mars's ancient waters, but potentially about whether the environment might have once been suitable for microbial life. The mineral composition of these structures could mirror similar environments on early Earth, where microorganisms thrived. Curiosity won't reach these remarkable features until early 2025, but the anticipation among the science team is already building. This investigation promises to add another fascinating chapter to our understanding of Mars's geological history and its potential for having once harbored life. And now, some more Artemis news. After extensive investigation, NASA has finally uncovered the root cause of the unexpected heat shield damage observed during the Artemis 1 mission. The investigation revealed a fascinating technical challenge that occurred during the spacecraft's revolutionary skip re-entry maneuver. The issue stemmed from gases that built up inside the heat shield's protective avcoat material during re-entry. Normally, these gases should have vented and dissipated, but they became trapped, creating pressure that caused cracking and led to pieces of charred material breaking away in several locations. What's particularly interesting is that this phenomenon wasn't captured in pre-flight testing. The ground tests used much higher heating rates than what the spacecraft actually experienced during its return. Under those more intense conditions, the material behaved as expected, but the actual gentler heating during Artemis IV re-entry created a different reaction, slowing down the formation of protective char while still generating gases within the material. Despite these findings, there's good news for future missions. The investigation confirmed that even with the unexpected heat shield behavior, the spacecraft's internal temperature remained remarkably stable in the mid-70s Fahrenheit. Had astronauts been aboard, they would have remained perfectly safe throughout the re-entry process. NASA's engineers have already identified solutions for future missions. They discovered that areas of the heat shield that were naturally more permeable didn't experience the same cracking issues, as the gases could escape more easily. This insight is driving improvements in the manufacturing process to ensure more consistent permeability in future heat shields. These findings represent a perfect example of why we conduct uncrewed test flights. They allow us to identify and solve potential issues before putting astronauts at risk, ultimately making future crewed missions safer and more reliable. And that wraps up today's episode of Astronomy Daily. I'm Anna, and I want to thank you for joining me on this journey through the latest developments in space exploration and astronomy. Remember, the cosmos never stops amazing us, and we'll be back tomorrow with more fascinating stories from the final frontier. If you'd like to stay up to date with all things space and astronomy, visit us at astronomydaily.io, where you can sign up for our free daily newsletter and catch up on all the latest space news with our constantly updating newsfeed. While you're there, you can also listen to all our previous episodes. Want more space content throughout your day? You can find us across social media. Just search for Astro Daily Pod on Facebook, X, YouTube, Tumblr, and TikTok. Until tomorrow, keep looking up and wondering about the mysteries that await us in the vast expanse of space.